The broadcast is now starting. All attendees are in listen-only mode.
So today we are going to discuss how to disrupt the enterprise storage industry with innovative technologies like 100 gigabit Ethernet, 200 gigabit Ethernet, RDMA over converged infrastructure. And your hosts today are Mellanox at StarWind. My name is Max Kalametov. I'm Director of Product Management at StarWind. We also have our guest Moti back from Mellanox, and we will just take one more minute to let a few more attendees join us and then start the presentation. In the meantime, I will kindly ask you to give us some feedback if you don't see the screen or you have any audio issues. You can use the questions and answers panel anytime during the event, either to submit feedback or to ask your questions. We will gladly answer them at the end of the event. All right, so it looks like the audio and video is fine for everyone. We've got our attendees here and we are ready to begin the presentation. So Moti, are you with us?
Yes, I'm with you, and thank you, Max, for introducing me, and hello, everybody. Thanks for joining. So just before dipping into the material itself, let's spend a couple of times about Mellanox. I don't know how many of you are used to work or know about Mellanox. So just to introduce the company. So Mellanox is a company that provides networking technology. Everything that you need to connect servers and storage in the data center, we have. So we have the end-to-end solution. We support all the standard technologies that connects data centers, including Ethernet and InfiniBand. Actually, we were the first to provide the 25 and above, or I would say more than 10 gigabit per second. And as everybody knows, specifically because of the new storage devices, 10 is not enough anymore, and I'll deep dive a little bit about it later on. But we have up to even 200 gig per second if you want. It includes, in general, we support all the components. It includes the Spectrum switch, the ConnectX. This is the set, the family of NICs, and also the LinkX, which is the cables themselves. Although cables usually are a very passive element, but it's pretty tricky to transfer 100 gig per second over copper cables. So we have the copper up to 3 or 4 meter, and also the optical. Our current technology includes Max, if you can go to the next slide. For some reason, I have technical issues to promote it. So our current family of products, and I'll start from the bottom, include, as I mentioned before, the LinkX, the copper and optical cables in 2 technologies, the traditional VCSEL and the silicon photonics. The ConnectX-5 that can support up to 200 messages per million messages per second, the Spectrum switch that you can see that it can support all the standard speeds that the Ethernet can provide today, the 10, 25, 40, 50, and 100. And we have software utilities that helps you to manage and configure the network itself, which makes the deployment much easier. If we move to the next slide, this is a couple of slides that I want to spend before digging or deeping dive into the technology itself. So what we see recently, and it's not a surprise, that the hard or the traditional hard disk drives that control the world for more than, I would say, almost 30 years are being replaced by the new flash technology. And there is an impact on the networking. So if we go to the chart on the upper left side, you can see that if we are just using the hard disk drive, you can, with 10 gig, you can support up to 24 hard disk drive on a SATA the interface. Or if you are moving to the 100 gig per second, you can actually support 250 of them. But if you are moving now to a SATA SSDs, that is the same SATA standard that the hard disk drive are using, with SSDs, you can support only 2 SATA drive on over the 10 gig and 24 over the 100. Moving to the right lower side, you see the same when you are using a faster protocol like the SAS protocol. Now it's 1 and 10. And the latest one, and actually I wouldn't say that this is the latest one, but the NVMe, you can have the one NVMe can support more than the 10 gig can enable or can deliver. And this is why we believe in saying that 10 is not enough anymore and that 25 is the next 10. And for all NVMe or flash technology in general, the default today is to use the 25 or above. I'm not sure that we'll have time to discuss it later, but of course the NVMe is not the latest technology. Recently started to see the persistent memory, but for this presentation we are going just to discuss the latest NVMe and the other flash technologies. So this is actually on the bandwidth side. If we'll compare the latency itself, and this is what you see in the middle, the latency, the impact is actually much higher or more significant. You can see in this particular case, you can see like much lower latency when you are using SSDs. And here you can see also on the persistent non-volatile, the persistent memory is a huge impact. So when you are choosing the right deployment and the right networking, you need to take into account both of them. The network can support the bandwidth and the latencies that the SSDs can support. And there is another another architecture change in the industry. The data centers are moving now for more efficient deployments. Although the slide is not, for some reason, the colors are not the right colors that originally for some reason, but you can see that the differences between the traditional solution to the converged and the hyperconverged solution. On the left side, you see the traditional solutions that is still using the two different I would say, networking technology. One is the Ethernet for the compute. The other one is fiber channel or ISCSI, or FCOE is not as popular, but let's say fiber channel and ISCSI. But you still fiber channel if you want to use it. It's a different network that requires different switches and different management, which makes it very complicated deployment. It works. The fiber channel, of course, has a huge install base, but is not as efficient and cannot scale to the size that the new deployment in the data center requires, especially if we take into consideration not just the speed, but also the amount of the memory, the big data that is available today to do or to make decisions. On the converged solution, you still have two separate I would say, compute node, or two separate servers, one for the compute node on the top and the other one for the scale out, for example, file server. This is the Microsoft name, but you still, but there are other solutions as well, including StarWind, that you can see that there is a different between different, I would say, servers for the compute and the storage. But on the hyperconverged itself, the same servers can be used for the compute and for the storage. And this is where actually you need even a higher bandwidth on the network itself, because the network can need actually to deliver not just the compute data, but also the storage on the same network. So the solution is much more efficient, but from the other side requires the network requirement is, from the performance point of view, is much higher. If we'll move to the next slide, just as an example to show why hyperconverged is more efficient and requires actually a higher networking technology. This is an example that compares 10 gig to the 25 gig. So it's basically apple to apples. You still can do it with the 10 gig, but when you are doing it with the 10 gig, you'll need more ports. It's not just the port itself, but also the cables, also the ports on the switch, and also once you have more cable and more ports, the maintenance is more expensive. Although the comparison here is only on the capex, only how much is going to take you to buy the same equipment to support the same functionality. And the overall saving when you are using the 25 is pretty significant. And of course, if you buy or if you build a higher performance, mean more nodes in the system, or you'll use faster flash memory to the like NVMe, you'll start to see even a higher saving and higher efficiency. And it's actually a must today to use to the 25 and not just to stay with the 10 gig. So it's pretty much, I would say, there is a consensus, I would say, in the industry, the 10 is not enough anymore, and the 25 is the new 10. And this is where actually Mellanox is leading the market. We were the first to provide a 25, 50, and 100 as well solution. And this where we can show higher efficiency with our networking solution. If we move to the next slide, and I want to mention actually that the network itself, there are two elements. One of them, if you remember, is the bandwidth itself. The bandwidth is important, but the other one is also the latency. And one of the most important parameters is that when you are choosing the right network is to see the efficiency of the network itself. Efficiency means that how much can be done on the network instead of being done on the CPU. Of course, everything you can do, no, I wouldn't say everything, but many things can run on the CPU itself, but the CPU is pretty expensive. It's about $2,000 for a CPU today. So why to use the CPU on running thing or functions that the network can do? And if you can choose a network that can offload network functions from running on the CPU to the controller, to the IO controller itself, then actually you are gaining quite a few benefits. One of them, you have more cycles to run the application itself, because the CPU is, is freed from running the transport layer. The second one is the latency. Once you're doing it on the IO controller on the hardware itself, instead of involving the CPU and the operating system, then the latency of getting the job done is shorter or lower. And as we showed before, the latency of the flash is much lower than the hard disk drives. And then the overall ROI and efficiency of your data center is much better. It's not a new idea. Basically, I put here the concrete track that basically, instead of taking a ready concrete from the facility or the truck gets the material, mix it together, and the compute, let's say, or the packet processing here is being done while the truck is driving from the facility to the location. So this is really the idea that Mellanox is promoting for many years. And if we move to the next slide, one of the technologies that are very well known in the industry is like the RDMA technologies that offloads the operation or the transport from running on the CPU itself to run on the I/O controllers or the, let's call it, networking subsystems. On the left side, you can see the operation. This is the traditional TCP operation that you want to move data from the left to the right, and then from the left server to the right server, from the file storage to the client. CPU is being involved. There are multiple copies from every time that the operation needs to do something. It moves in stages, and each stage requires a copy and another operation. And then the same thing on the transmitter, let's say, and the same thing on the client. On the RDMA, remote direct memory access, this is a technology that is being used for almost 20 years. You can see that the transport is being offloaded to the controller, the RNIC, the RDMA NIC. The CPU tells, the controller, move the data from this memory, from this specific place in the memory to the client memory. Tell me when you are done. So the NICs are communicating between themselves. CPU continue to work on the real application. This operating system, everything run in a user space. Operating system is not being involved, so the jitter is much lower. It's always, I'm giving an example that we can always do business directly between us or via the government, the operating system. Every time that you're doing it through the government, of course, it's being done, but the delay and the resources are more expensive. So this is a good example of an offload function that the network can do or doing today. There are some other offloads that we can do, like Razor coding, but we are not going to cover it today, but we'll focus mostly on RDMA. And RDMA is a technology that started, as I mentioned before, like 20 years ago, but it started in a network technology called InfiniBand that is very high performance. You can find it today in many applications, including databases. But about 4 or so years ago, the Ethernet industry decided also to add RDMA technology to Ethernet, and there is a standard called ROCE, RDMA over Converged Ethernet. And you can see on the right side some charts that actually compares the throughput and the latency from between TCP/IP and ROCE. So the nice thing about running RDMA over Ethernet is that you don't need to have any special equipment, the same cables, the same switch, but you need, of course, to have RDMA capable NICs. This is where Mellanox comes and provides it, and actually we are the leader and working with companies like StarWind on making it to provide the complete solution. And you need some, if you want to take full advantage of the RDMA, you need to program the switches or through ECN, or very easy a configuration or through priority flow control. But if you don't want, you still can run without any configuration. It's still going to provide you better performance than running over the TCP/IP. So when you are running, the latency is much lower, the bandwidth is higher, the overall bandwidth. When I'm saying bandwidth, of course, you can get the same bandwidth when you are running even over TCP/IP, but then the CPU utilization is going to be much, much higher. And I have some examples that I'll show you that I'll show you in a minute. And all the major operating systems, including Windows and the vSphere and the Red Hat and KVM, all of them are supporting and have inbox support for the RoCE today. So this is a technology that gives you the best of both the bandwidth, the latency, the CPU utilization, and very low jitter if your application requires stable and fixed low jitter, for example, for application like high frequency trading. So I mentioned a couple of examples. This is an example that I took from a benchmark that was published a couple of years ago, I believe, or maybe a year ago by Microsoft, that they are using the RoCE, their storage spaces direct. And when they connected two servers together over 100 gig and compare the results, RoCE versus TCP/IP, this is what we call it without RoCE, the overall bandwidth was 2x better for RoCE. And it was 2x better on bandwidth. It was actually much lower on the CPU utilization and also on the latency itself. And then we tried to analyze what was the reason for doing it, why we got such a good results or better results over RoCE. And we analyzed the CPU utilizations. And when we ran over TCP/IP, all the 8 cores that were allocated to run the transport and the TCP/IP were actually fully utilized. And once we compared it to the RoCE, none of them was fully utilized. Of course, it was some performance needed but overall, almost 100% of the CPU was available to run the application itself. So again, just showing the strengths of the RDMA technologies that the RoCE enables today. If we move to the next slide, there are other technologies, storage technologies that are using RDMA. One of them is ISCSI, which is ISCSI over RDMA, called ISER. The nice thing about ISER is that you don't need to do anything on the protocol stack. Everything that runs over ISCSI will run as is over ISER. The only thing that needed to be done is to, of course, to have NICs that are RDMA enabled, and you can see the performance gain that ISER is enabled versus ISCSI. Not just the bandwidth or the throughput itself, but also on the CPU utilization, as I mentioned before, at least 50% less. And the last technologies that we are going to discuss is, I wanted to mention the NVMe over Fabric, but we'll see if we'll have enough time to cover it later. And I move the microphone to Max at StarWind to describe and to present the solution itself.
Okay, thank you so much, Motti. And yes, so we work with Mellanox technology for quite a while already, and 2 generations of our hyperconverged appliances run on Mellanox RDMA-enabled backbone. And a lot of people using our software-defined storage also use Mellanox as their interconnect. But this time we decided to bring Mellanox to a place where its performance capacities and characteristics will actually be challenged. And this year during VMworld, we presented a new solution called the Enterprise Storage Appliance. Back in the day, we just gave it a code name, Fractal SAN. And let me tell you a little bit more about it. So I guess main question would be, how is it different from all other SANs on the market? Well, the idea is to use StarWind's performance combined with the scalability of open source solutions like Ceph. And here is how we do it. We've got our controller nodes on top, which do provide multi-protocol storage. They've got ISER, SMB, SMB Direct, and also providing NVMe over fabrics if needed. And they have fault-tolerant RAM cache, flash cache, and cluster metadata storage. And those are standard x86 servers interconnected with Mellanox ConnectX-4, which gives us a single, let's say, brain pool for the entire cluster. And we got the capacity nodes, which run on ARM, and every ARM node runs on Ceph. So each node from this storage shelves is comprised of the capacity drive and an ARM PCB. We managed to get Ceph running here. We've got redundant gigabit connectivity. We've got less than 7 watts power requirement for it, so makes it a really green solution. And we've got SMR hard drives, meaning that we can use archive drives and get archive drives to deliver performance in primary storage environments. Now, what would be the main benefits of this solution? First of all, it's going to be high performance and extremely green solution in terms of storage. And then it's infinitely scalable. So you always use StarWind for performance and fault tolerance capabilities, and you always use Ceph for scalability. But you didn't really know Ceph for performance-intensive applications workloads. In this case, we combine the two together to deliver both performance and scalability. Then on top, since we run RDMA-enabled backbone and triplicate the metadata, we've got outstanding resilience. We can erasure code or mirror the storage on the Ceph level for any given virtual machine or database. And then it also scales really linearly, since you just add one storage brick at a time. So storage brick would be the enclosure, your minimum scalability unit. And it is also a unit which is the fault domain. So if something breaks, you don't lose the entire JBOD like in typical storage solutions. In case of StarWind Enterprise Storage Appliance, you only lose either a drive or a controller for that drive, or one of the controller nodes. But in any case, the resiliency is much higher and the rebuild rate is much faster. So this solution architecture is meant to deliver much better service to companies who want to benefit from high performance, highly scalable storage. Now, getting a little closer to where we worked here with Mellanox, the capacity nodes were just running 1 gigabit Ethernet. It's completely sufficient to saturate the queue for the SMR drive. Then as we go higher from the gigabit switches, we run 10 gigabit uplinks to the StarWind nodes. But on the StarWind nodes, without 100 gigabit Ethernet, with RDMA, there would be no option for us to keep the performance high and replicate all those RAM and flash caches without slowing down the customer applications. So this is where Mellanox ConnectX-4 really helped and made it possible to create such a solution. And the switches we're running behind 3 nodes are where Mellanox MSN 2100. And in this solution, which we're rolling out to the market next year, it's going to be maybe the default switch, or if Mellanox releases new switches at that time, it may going to be the next generation of Mellanox switching equipment. Now, Motti already showed before some benefits, and I'm going to talk about the RDMA benefits as well here. So in a typical system without RDMA, we are just using local RAM and local flash as caching. And as it fills up, we're flushing the data down to the storage level. And applications typically see the latency of us synchronizing the cache between the 2 nodes. Obviously, it's synchronous replication, so it should be there. So what Mellanox allows us to do is to minimize that latency between the nodes. So we now treat our RAM in different machines as essentially just a single memory pool, and moving data between the machines is really easy and really fast. And this is the first benefit. The second benefit is the IOPS we're getting, because if we go RDMA, not only on our internal interconnect, but on the external connections, we've just ran a few quick tests on ISER versus ISCSI. And here's what we got for IOPS. We've got 2.5 times higher IOPS with ISER, which is like 40,000 versus almost 110,000. And this also came with the same latency improvement, where we really get to this sub-millisecond latency with ISER. And all of that came with just a slight CPU utilization increase, part of which was actually generated by StarWind's previous generation core, which is now also updated. So this test should also be redone to show that we're now below 10% for both ISCSI and ISER. But in any case, we just utilize maybe like 8% of the CPU to get 2 times improvement of our performance and 2 times improvement of our latency. This is tremendous difference, especially for a storage system, and for a hyperconverged system, this is even a bigger difference. And that was all from our side. We will have other events showing how we benefit from the RDMA-enabled technology in our new hyperconverged appliance generation. And for now, we would like to start a quick questions and answers session for our attendees. So should you have any questions regarding Mellanox or StarWind or our combined solutions, feel free to use the questions and answers panel in GoToWebinar to submit your questions. Thank you. Okay, and we've got our first question. And this one, I think this one's directed to Mellanox. So we've got Jack asking us, what is the best way to get RDMA to work with 2 hosts which are connected through a series of 2 different Mellanox switches?
2 hosts that are getting connected to do 2 different.
Yeah, so I think it's something that Monty, you described earlier. We had this conversation the other day when we were discussing that a lot of people get that confusion that you cannot make RDMA work through more than one switch.
Yeah. So I didn't publish, actually, I think that maybe I published, can you go to the slide about Rocky? I don't know if you can go there.
I can really go there. Yeah, real quick. Just 1 second.
So by the way, this is a very common question that we are being asked about the complexity or the what is needed to run Rocky. And yeah, so as I mentioned before, so there is you can run Rocky on as is, but and the performance is going to be better than the TCP/IP, but not as good as if you configure the switches. And there are two ways to configure the switches. One is using the ECN, and the other is the priority flow control. ECN is very easy, one command line to configure the switches, and regardless how many switches you have. And there is a configuration examples, actually I had to, it would be better if I put here, if you can see the link itself, but if you do Google and you will ask Meg with word Rocky configuration, you'll probably get to our community site where you have examples and the command lines that you need to use in order to configure under ECN or the priority flow control. The priority flow control is a little bit more, today, a little bit more complicated mechanism. We are working to make it easier. And hopefully in the near future, we'll also provide, the plan is to provide the automatic utilities that will do it by itself. Overall, I believe that the performance gains that you are getting when running over Rocky, when you are doing the configuration using the ECN or the priority flow control, justifies the effort. But again, we'll work to make it even easier compared to what you're doing it today.
Okay, thanks, Monty.
So,
I guess there is the second question. Can I use Mellanox RDMA if I don't have a switch between my StarWind machine?
Yeah.
Okay. Yeah. It will still work. So if you have the standard minimum StarWind configuration with just two servers directly connected to each other, you can still benefit from the RDMA technology between the hosts. And the same will actually work if you connect some systems to it as storage consumers. So in this case, RDMA will work without a switch as well. In 3 nodes, we recommend that you start using a set of 2 switches. Moti, what would be the typical system for a small storage environment? I remember these half-wide switches we
Yeah, so one of the things that we did, I think that Mellanox actually is the only one in the industry today that is a switch that is half the same depth, but half the width. Specifically for storage, sometime, in many cases, you don't need too many nodes. So you can use the 2100 that has 16 ports, half width. So you can put 2 switches side by side. So you have the high availability, but no, you are not losing, I would say, 1U space if you wouldn't have it. So for small deployment, you know, if you need a switch, sometimes you don't need a switch like the StarWind, you know, there is a back-to-back or a star topology. You don't need more, and you don't need more than like 16 ports. You can use the 2100. If you need more, then there is other, you know, the other one that can support 32. And it really depends on the bandwidth. If you don't need more than, for example, 50, you can still buy the 2100 that can support each port 100 gig, but you can use a splitter cable that take each one of the 100 gigs, split it to 250 or to 4 of 25. So it really depends on the deployment, but definitely for lower or smaller cluster, the 2100 switch is the best solution to go.
Perfect. Perfect. And I guess there is one more question. It's not really about the RDMA technology, but, well, still a valid one. When does StarWind plan to use Skylake-based platforms in the hyperconverged appliances? So luckily, we are finished with the new product line, and you should be able to start using them from 2018. So beginning of January is when we're planning to roll out the Skylake-based hyperconverged appliance, storage appliance, and backup appliance lane. And there will definitely be some changes there. So more CPU options as well as more core options. So stay tuned. We're almost there. Okay, I guess this is all for questions today. And if your question wasn't answered or you decided to submit it later, you can always email it to us to either sales@mellanox.com if it's about Mellanox, or to sales@starwind.com if it's about StarWind. You can also mention us on Twitter if you have any question, and we'll gladly answer it. Thank you for joining our today's event, and bye-bye.